Okay, your exam next week. We haven't covered anything kind of crazy. We have been reviewing basically one thing. So what you can expect from your exam is something easy. I am going to ask you to show me that basically you have been here and you understand the things that we have been talking, most of them more than one time, right? So after that, we can move forward with new tools and new things, but I need to check in the meantime that so far, so good. At least people here. Good. Okay, now, before that, important things. I am going to send you an email. I am going to send you an email before the exam, and in the email, I am going to ask you to sit in a particular place. Just to give you some reference, I am going to tell you what is your place, and your place could be row 1, 2, 3, 4, 5, and so on. 1 is the one in front. Moreover, A and B. So 1A, 1B is like the column. A, the one that is in my side, the instructor, B, the one. And your chair. Your chair, 1, 2, 3, 4, 5, and so on. 1, 2, 3, 4, 5, and so on. So looking to the whiteboard is 1 to the left. Make sense? So if I ask you, for instance, okay, you should sit in 2B, chair 3. So, over. What I am going to do is that the TA is going to sit with me, and we're going to give you your exam. My expectation, if everything goes well, your exam is going to have your name. So when you are there, we're going to check that you are in the correct place, check your name and give you your paper have your name, and you just worry about answering the questions. Make sense? Highly recommended, please, pencil and eraser. I know that you need pens usually. It would be a very bad idea to use your pen. You are going to write some source code. I am going to tell you more details, but I am sure that you are going to change your mind for some question. So it is better the pencil, please. Good. And it is okay. You can keep your answers with the pencil. Something that I do immediately after you give me your papers, all your papers are transformed to PDFs. So I have a copy in PDF of your exams. That's it. So I don't care if it's pencil or pen. I am going to return your paper. The only thing that I'm going to review is the version that I have, not the paper that you have. But second thing, guys, usually the camera is recording me for the people that could need the video later, if anyone. The day of the exam, the cameras are recording you. So you are doing your exam, the camera is checking you, and the TA and myself will review the video later. The camera is there, and it's kind of over things. So believe me, we record the video. So yes, the day of the exam, maybe the TA is answering a question here, and maybe I am talking here, and you think there that you can share ideas and papers and so on. I already put 4 zeros previous semester, just because of that. I do not want to do that. I mean, people in the dean office almost know my name because the number of I mean, really, I do not want to do that. So please, don't. Really. Well, check the video. 5 minutes talking with your friend, and it's in the video, and you get the 0 in the exam. And if you try to do the exam by yourself, I am sure that you can perform better than the 0. So check that. But, that is one of the reasons, because I am going to give you your seat, so I know in the video where you are. Anyway, so academic integrity, take care of that. Anyway, so for the exam, again, I think this will be the easiest one in all my classes, because it's basically one topic. And I am going to be asking you 3 kind of questions, 3 things that you're going to have there. As usual, easy questions, 5 points or something, 5, 3, 1, around that. Theoretical questions. Theoretical questions. What is something? What is a neural network? What is learning rate? What is a network? And so on, concepts that we have been using here. I am going to ask you for Hermit. I need to know that you know what is the meaning of this. Now, those questions, don't worry, you do not need to memorize anything. Those questions are going to be multiple choice. So what's an epoch? And you're going to have A, B, C, D options. You do not need to memorize the definition, but remember the concept, and therefore being able to select correctly one of the options. Makes sense? So really, I want you to show me that you remember the concept, but I do not want to force you to memorize definitions. I do not want to review your definitions and figure out what you write. It's just circle the correct option, A, B, C, D. Clear? Obviously, those questions are 5 points, 3 points, 1 point. They are easy. Good. As usual, remember. 2 exams, they look similar, almost the same, but in particular, those multiple choice questions, if you think that are going to be the same for him or him, if they are together there, so close, they are not going to be. So don't worry about your friend. Again, it happened. My friend had all the options true. I am going to put everything true. You know what happened, you have read that. Your friend is going to have 100, but maybe you're going to have, I don't know, 50, 60, because you don't match exactly right. Anyway, so multiple choice, I am going to mention the concept right now. I am going to give you an idea of which concept I am going to ask, so to make sure that you remember them or you need to review them, whatever. Multiple choice, one thing. Second, I am going to show you source code or data, source code or a confusion matrix, source code or the value of precision, recalls, and so on. A picture. For instance, I create this model, I run my model, this is my confusion metric, or these are the performance metrics that I get. And the question that I am going to ask you is, do you think that is a good one or not? Or the source code, hey, this neural network is convolutional or not? How many inputs do I have here? How many outputs? Can you explain it in the model? I am going to give you something that is already done, and I am going to expect that you help me to tell me if you understand the source code, the model, or the meaning of the metrics. Makes sense? Again, it's 5 minutes. We are going to review the numbers. Can you check a confusion metric or a recall or a precision value and know if it's good or not? And hopefully everyone tell me, yes, of course. Those questions, usually 10 points. Something greater than 5, probably 12 in some scenarios, depending on the complexity. But as you can notice, theory, 5. Questions about show me that you understand something, 10, 15. And the third one, probably the last one, and it could be 1 in your exam, or 2, depending on the type. But in one question, at least, I am going to ask you to do source code programming. In particular, to be honest, what I am going to ask you, the most important part of the source code that I am going to check that you remember is to create the configuration for a model. I give you the source code for the libraries and the network from scratch and so on. Obviously, there are going to be some questions related with that. But the question that is the big one is give me the configuration for a particular problem. So you need to remember how to create this configuration, the layers, okay, the numbers. What does it mean? Number of inputs, number of outputs, the parameters for this and that. That configuration that you have done in several different homeworks and quizzes and so on, review that. 25 points, 20, 25, depending on your exam, is going to be connected with that question, one question.
So, do we need to justify that the model is good? So just one line.
So in that one, in the question that I asked you for the source code, probably what is going to happen is I give you the parameters, or I give you some options for the parameters. And I am not looking for the perfect model because you do not have way to run and test. So basically, I'm going to review that you can put the parameters in the correct place. If I mention the learning rate, that you can put that in the correct place. If I mention some kind of updater, that you remember what that is. Inputs, outputs, that you can connect correctly. If I ask you for a hidden layer, that you remember what could be the size for that. Again, I am not expecting a particular number, but that you remember some rules about, okay, this cannot be higher than this, or it should be smaller than that. I am going to check that the 3 rules that I give you, the 3 options or others, that you follow at least one, right? Nothing crazy there. So mostly that you can create a model. And for the performance, that is going to be the previous question. The other one, I give you the performance, I give you the screenshot of this was my model. You do not need to know the parameters. This is the result. Tell me, is good or not? And believe me, I am going to be kind of 60% versus 99%. And I am going to ask which one is the better. So it's like there is not going to be middle point like 95.3 and will not be very separate values. And if you remember these ideas of what is good and what is not good, you're going to move forward.
So we need to justify that the model is good. Just saying that.
I am not going to ask for justification, not for a model, not for a model that I give you. You can put some justification. In particular, what is going to happen? The correct answer is the number. I mean, if I ask you if this is good or bad, the correct answer is just yes, no. Just because you remember what is good and what is not with numbers. Right? If by any chance in any of the questions you feel like it's a good idea to put some extra information, like a justification, go ahead. I mean, I am not going to put the question wrong just because you write something. To be clear, I am not asking you to do that. But maybe if you put something like that, when we rate, we can kind of consider you kind of process and okay, maybe it's not the correct answer, but you have some idea, but you get lost in some point. I don't know, we can try to use that to help in the grade, but it's not requested. You can just put the number, select one, that's it. Clear? So those are the 3 things that you're going to have. My expectation, you can finish the exam in less than 1 hour. Again, nothing long, because the longest thing that you need to write is a model, and as you remember, it's half of the page. You do not need to think a lot about it. Basically, you remember where the elements go, you can finish in half an hour probably, but if you have time, so my expectation is less than 1 hour, you are done. Again, if you remember everything. We have the full lecture, so we're going to leave here until the end of the lecture, 1 hour, 15 minutes, so you can kind of check, double check your answers. Again, the cameras are running, so at the end of the lecture, when people try to verify with the classmates, bad idea, hopefully it doesn't happen. Anyway, content. And I am going to try to point out in 7 different things. 7 kind of moments that we have covered so far. This picture, first week, is a very good source for questions that are theoretical. We talked almost 1 lecture about the elements here that are in circles. Obviously, what is machine learning? The definition is there. We talk about it. It's in red. The question is going to be there probably in your multiple choice questions, but the others. Supervised learning versus unsupervised learning. What is the difference? What is supervised? What is unsupervised? What are the input for supervised? What are the input for unsupervised? Do you remember?
Yes, we have the results.
We have the result output.
Actual answers and structured in that.
If you're thinking about this Excel table with X and Y's, and when you have the X and the Y's, that is going to be okay. We can move forward, right?
Yes.
Okay, and what is machine learning and what is the difference with artificial intelligence? Hopefully that is also another one that you remember. which one is more powerful?
Yeah.
Okay. Machine learning is.
Subset.
So I'm not going to stop a lot up here, but there is a full lecture. We talk about it, worst case scenario, review the concepts, multiple choice questions. Use the same that I ask you right now, and you give me the answers, correct answers. You don't need to memorize them. Multiple choice questions, A, B, C, D, the one that match with the concept. Good? Blue ones. Now, we have been working with neural networks at the semester. Here, important things that I want you to remember, and I'm not going to go through everything, but if I talk about W values, do you remember what those are? Where they are? If I have an error with 3 inputs, can you agree that I have 3 W values?
Yes.
Do we understand why we have those 3 W values? We can connect those W values with the constant in an equation. Okay, activation function. Can I ask you in the theoretical question, what is an activation function? Moreover, next slide, can I mention names of activation function like the signal? You know what I am talking about. Theoretical question, if I give you some equation or some value and I tell you that the signal for that one is a particular value, I mean, I am going to give you the information. I do not expect you to memorize this. Forget about it. But I expect you to understand what I am talking about if I tell you that 6 is the signal function for whatever, 1, 0. That you understand what I am talking about with signal or linear. Activation function, what they are, and what options do I have important. Now, talking about activation functions, I give you this picture at the beginning of the lectures, the week 2 or something. From here, we have worked practically with this one. You did source code, we did models using this one. The SIG model is something that you have tested practically. And in some point, we stopped using the SIG model and we moved to that one. Do you remember what was the reason? Because goodbye to this one and welcome that one.
Image recognition. Image recognition.
Image recognition. Why we changed the SIG mode for the other one in the image recognition?
SIG mode is better for the classification models and that is better for regression.
Good. I am not going to go to the details about tell me which one is good for what, but can we agree that there are several different activation functions and each activation function is connected with solving a particular problem? And in particular, we have used 2, one for images, that is the only thing that we have done so far, and it's not the SIG mode, and other things, including the XOR operator and maybe migrates and the ID data set. For that, SIG mode works. Those 2, this and that, you have used them, you know the difference between them. I can reference them, mention them in the questions, and you understand the question. Again, I am not going to ask for the equation, mathematical background, just that you remember those names. Good? Okay. Activation function, other than the activation function, other than the W's, something that we review is like, okay, we can put together several different neurons. And then we can create this network. And for the network, obviously we understand the concept of what is a neuron, and obviously we understand the concept of what is a layer. How many layers? How many layers in a neural network?
At least 3.
At least, right? Yeah. This was my easy example. How many neurons in each of those layers?
0 and input 1 and out, or depending on the problem, multiple.
Okay, depending on the problem. Perfect. If I give you the definition of a problem, like your example was the XOR operator. In the XOR operator, can you remember how many neurons in the output line?
One.
For the digit recognition, how many neurons in the output?
And
For the iris data set?
three.
Okay, 3. Okay, that's fine. There were 4 input, exactly. 4 columns, 4 numbers for the input, but the output is 3 categories, so you have the output of the category, and each output gives you the percentage of the problem. Whatever. Can I ask you how many neurons in the input, how many neurons in the output? Obviously, I need to provide the problem, but so far I mentioned the hybrid data set, I mentioned the XOR, because you have worked with those. If I explain to you a particular data set, for instance, I give you in the quiz the grades of my students, and for the grades of my students, not the best example for a neural net, but I give you that. In that problem, how many inputs did you use? I am going to problem. Yeah, kind of the quizzes, the exams, and the others. Okay, all the columns. How many outputs? How many neurons in the output data set? Okay. The letters, the grades that I am looking for. Okay, if you know that, it's like, okay, we can move forward. Hidden layer. Here is what we told before, right? It's like, okay, how many neurons do you need in the middle layer? How many middle layers do you need for a model? And we go back to the idea like, well, you're going to have one at least, but depending on your problem, you can have more, you can play with that. But the number of neurons, there are some rules, right?
For more than another.
What if I go back to my problem with the grades of my students and I told you, you know what, for calculating, predicting the grade final of my class, you have these 14, 15 inputs and you have these outputs that are 4. So 15 and 4, we are going to put a hidden layer here. How many neurons there if I have 15 here and 4 here? There is no one single angle, right? Remember? I mentioned at least 3 rules that you can follow. However, 100 in the middle. 2. I can give you an A, B, C, D, and some options could be like 1,000, 100, 2, 1, and then I can put the correct ones. And the correct ones, either you answer C, D, or I, they are going to be fine, but there are others that are crazy wrong. That is what I am going to rate, period. Good? Okay, those 3. Do we have others? Just to put them here, but I am going to talk about them at the end. But the last class that we covered was convolution, right? And for convolutions, I think you discovered that we have 2 new types of layers. The convolutional one, right? And another one. The one in which do the polling or the subsampling, whatever you want to use, but 2 more here in the model. The last 2, only if the model is convolutional. Remember, one for the convolution and the other for the subsampling or polling. But still you need input, output, at the end. I'm going to talk at the end. Good? Good. Perfect. Now, if I show you this picture, how many W values do we have? How many bias values? By the way, bias. What is bias? A question for the theoretical background. How many values for bias do we need in this model? My only idea is you remember that those elements with the inputs are creating an equation and what they are and where they exist in the model. You have all this information. We play with this. One of the homework that I ask you to do is literal, to match this picture with values in your program. The values in your program, that was the question. Review that code. Again, I do not need you to memorize the code. I am not going to ask you about the question, partial derivatives and so on, forget about it. I just need to be sure that you show me that you understand where those elements are when we talk about neural networks. Clear? Other than that, we talk about the error function or the loss function. And if I remember correctly, the first one that we started using was random. Moreover, you implement that one from scratch in some source code. What is an error function? Because we have activation function. Error function. Can you define that?
Calculates the distance between the predicted output and the limit.
Okay, I like that. Again, remember, I am not going to ask you to memorize that, but you can select the correct one in kind of a list. Okay, we use this one first. What other we use? I'm going to use the letters. We use those two at least. So at least you are familiar with those two guys. By the way, activation. One more, because this guy worked with this guy, right? If you remember these names and why they are different and how did you use them before, going forward. Tell me why we use this one instead of the one that we have been using, the easy one. Do you remember that the key idea here? Probabilities. And the same reason because we moved here, probabilities. If you need to do a model, your model is going to handle probabilities, one of the recommendations, something that we review, we move from one model to another, checking the performance. Probabilities, the second one. Okay, you don't need to worry about it. It's just one parameter that you need to configure in a model. But if I ask you for a model that is going to deal with probabilities of things, like the pictures, the second one is your choice for the error function, right? Okay, talking about the error function, something that we review and is a good source of information for the concept is propagation. We talk about back propagation and forward propagation. What is the difference between them?
Initializing the weights and then fine-tuning it backward using that function.
Tell me, we calculate the W's in the forward propagation or in the backward propagation? The backward is to calculate the W's. What we calculate in the forward? No. When we apply the error function at the end of backward or at the end of forward?
Forward.
Okay. Before the backward. Okay, so far so good. Second part. Very good thing to remember that in the backward propagation, there are partial derivatives involved, in particular gradient descendant. Nothing that I am going to be asking you is not a calculus class, so I am not going to evaluate that part. Well, not in that detail. However, I am going to ask about operators, but I am going to mention that later. So, gradient descendant. Part two, moving to the part that I mentioned before about source code. In your exam, we're going to have something like this, smaller parts of this, something that I need to recommend you, need to ask you. If you have this picture in your exam, all the picture of a partial part of the picture, do we understand every single line there? If not, that is something very, very important to review. Because again, one question is going to be to write things from the line 24 to 38. 20 points to write those lines. Obviously for a problem that I am going to particularly describe, but the rest of the things, there are going to be small questions about what is happening here or there, or the result, or use part of the structure. We are going to have this. You need to understand where here is the training part, where here is the architecture of the model, what are the inputs, what are the outputs. If you have this source code, being able to draw the network that corresponds to that source code. Remember when you did UML diagrams to source code or source code to UML diagrams? Not exactly the same thing here, but your source code and the diagram, the net. Or at least tell me input, output, and layers, the structure. Good? If you can do that, moving forward. Now, parameters. I told before about a good model and a bad model. In general, for your exam, what I am going to be using as a parameter is the same thing that you already noticed, that number. We have been talking about this 95%, or we have been talking about this number in red, 0.05, like the limit for considering something that is good. It is, again, it is not a magic number. It's just the number that we select to use. It's the parameter, the threshold that we have been using. I am still going to consider that number for the question that I could ask, because I assume that we are in the same channel with that number. But what is better? Higher or lower that number? Okay. Now, source code. All the concepts that I described there, not mandatory, but a good thing that you can do is to be sure that you understand the source code that you're using on homework, the source code that is in GitHub, that is basically the implementation from scratch of a neural net. Again, I do not need to be proficient in backpropagation and what is happening there, but at least why these things are there, how these things are connected with the theoretical background that we described. Understand the connection of the big picture. Oh, backpropagation, forward propagation, when that happens, how that is connected with error calculation. Okay, sigma, oh, the activation function, in which case this one is called. Things like that. If you can connect this, or the previous one, or both, with the draw of the net and understand the process. Again, you can forget about the equations, but the process in general. Good. Theoretical question, and also questions about endpoints, source code, what is happening here, there, numbers, good or bad, this screen. Those are the things that you're going to have. Source code, what this is doing, what happens if I remove this, what happens if I change a value to other thing. Be sure that everything in the slide, source code and values is understood. Now, moving forward. The next part. A big part of your exam is going to be about deep learning for J. That is the library that we have been using. You have 2 or 3 homeworks with that, and quizzes. For sure, I am going to ask you about the library. My assumption is that you have been working with the library to solve your homeworks and your quizzes, that you are proficient doing that. If by any reason you work with your friend and your friend is the one doing the programming, ask your friend to explain what he or she did with the library, because we are going to have questions about that. So you need to know about it. Makes sense, right? Good. So the library, it is not the only one. It is the one with Java. We talk about the library, some questions, theoretical questions about the library. The answer can be found in the slides. But the most important thing is to use the library. using the library. I am not going to ask you for source code from the scratch. I am not going to ask you to give me this source code there from scratch, you writing things. However, probably I am going to give you something like this as part of the question. And my expectation is that you understand what is happening. For instance, if I show you this source code, I need you to know what these numbers are. And moreover, I need you to be able to map this to this. Because remember the problem that I give you with the grades of my students. What if instead of giving you the CSV file, I cannot give you that in the exam, it will be a lot. But what if in the exam I put some source code like this, but instead of using only 2, I give you here, I don't know, 4 numbers. Final average of quizzes, final average of assignment, midterm, and final exam. 4 numbers. Yes, I know, 4 numbers is not enough for a neural net. In the exam, the only thing that I want you to show is that you understand the process, right? So I can give you 4 columns, and I can give you some rows, 5 rows, whatever is enough in the page, and then ask you about playing with that data. What you need to remember is the only thing that I am going to give you is this. Do we understand this? If yes, good. If not, please review it. You can have a question with this data. You need to understand what is happening. Why? Because the number of columns is the number that you need to use for the input of your neural net. So that number is important for you to get it from here, and so on, right? Source code for putting data like this, initialization, either only the input or the input and the output, creating a data set. By the way, what is a data set? What is a data set iterate? They are classes. Yeah, they are classes. What they represent. Tell me, what is a data set?
Data set will complete data set input and output, but iterator will give you the batches. Right?
I am okay with is input plus output. Those are the key ideas. Your data set is both things, right? The X and Y's. Okay. Now that we're talking, about the data set, the batches. What is a batch? Split data set. What is an epoch?
The number of times you go through the data.
Remember, you do not need to memorize that. It's just multiple choice question for you to select A, B, C, D, the one that match with the answer that you are giving me. Yeah, good. So next. I am going to start with the easy one, but this you are going to notice that there are going to be more slides moving from this one to the convolutional. That was the final one that I showed you in previous lecture. You need to be sure that 100% you know what the things are here in the red rectangles. So my expectation is that you understand everything, the source code that I showed you before. But okay, everything is too much to ask. Is for the 100 in the exam. Okay, let's go to the 80 in the exam. 85. At least, can you explain? Can you use? Do we understand exactly what is the meaning of those things in red? Why? Because the last question, again, the open one, is going to be to create a model. And to create a model, that could be something like this. I am going to tell you the activation function. I am going to tell you the error function. Maybe I tell you the data for the inputs and outputs. I give you the data set, and from the data set, you can calculate the inputs and outputs. And then you need to create a model, and to create a model, you need to give me that source code, and that source code, those rectangles are the ones that you need to change in your exam. Everything else is memorization, practically. Again, yeah, you need to memorize things. If you are learning programming, you always memorize libraries and commands and public static void main and so on. I am not going to review, or I am not going to care a lot if you make an error in the things that are not in a red box. So maybe you forget the build here. Okay. I don't care. Maybe an error on the O or the I is uppercase, lowercase. Okay, I don't care. The parameters. The parameters are key elements. Those are going to increase or decrease a lot your particular grade for a particular question. Makes sense, right?
And we ignore the indexes of the layers too, because
These things?
yeah, like layer 1, layer 0, it can be ignored.
You can, the only thing that I want to ask you is, please remember that someone is going to be grading your exam, your paper, the TA or myself. Try to be as clear as possible, right? So the best way that you can put in your paper, what is the configuration of one layer and what is the configuration of the other, use to facilitate the grading. Because maybe you're going to have a small space and you're going to put everything in one line. We're going to do our best to search like, okay, these the inputs, the outputs, and so on. It's going to be kind of time consuming. We will appreciate that you kind of try to put things in order, but it is not mandatory. It's not something that we're going to take you points for. Do not follow it.
We can also mention the activation function at the global level.
Yeah, you can do that. In my example, you notice that I put the activation kind of in each layer, so to be sure that you know that that parameter exists and that you can change it, that you can put in the global part and it is applied to all the layers. Fine. Good. So there is no one particular answer because again, we are not going to compare automatically with some kind of predefined answer. We're going to search for, key ideas. Help us to highlight those key ideas because, these are the key ideas. So just make sure that the TA or myself, whoever, is going to kind of be reading that part. Worst case scenario, we miss it. Later you can kind of review with the TA or with me your exam and okay, here was the part, this part or not. But help us to kind of grade your exams quickly.
So we have some overloaded versions of methods like Midterm. So should we know it?
It is fine. I am not going to kind of go back. Clear? Now, small issues or small things connected with the previous thing. Learning rate. Going back to the concept, what is the learning rate? What is a good value for the learning rate? What is better, a high value or a low value?
Difference will increase if you make it.
As for everything else, is the good value depends on the problem. Important thing to know is what is the meaning of the learning rate, and the meaning
Increase it, the difference between the subsequent values increase.
Gaining the error function.
how fast, how slow we're moving, how fast or how low we're moving. Yeah, because remember that is basically a constant that we're using to multiply. If you remember the equation, the error constant, the error rate is a multiplication factor. So that factor is helping you to increase or decrease how fast you move when you're calculating this gradient, right? The gradient times this. High value, low value. Move fast, move slow. Slow is good, but if you are too slow, you can create problems. Fast is good, but if you move too fast, you can create problems. So it's like something that you need to discover according with your problem. if you understand what I am talking about right now with this learning factor of multiplication constant and what happens if the value is too big, too small, if by any chance you play with your source code and you put a value there like 1 and then you put 0.00001 and you run your program and notice what happened and crazy things happen really, you can move forward. Okay. Professor, you are not telling all what is the correct value. No, because there is no one correct value. What I need you to know is what happens if you put too small, too big, and hopefully you have the opportunity to play with your source code. If not, please go ahead or at least check the picture and these problems that happen with too fast and too slow, or at least remember that this is a constant part of the equation, the one that you multiply with your radians. Good. Okay, so that one. Remember this picture is the representation of this. The number of W's, the number of bias. I already asked you this, but I need you to remember that you can print this information for any neural net that you create with the library. We did it in one example, but you can do this with the one that you create for the quiz, right? So this question that I asked you about how many W's, how many bias, and so on, you can ask the same questions to yourself about the network that you create with the quiz for the exam. And you can validate that your answer is correct just printing this for your network. But my point is you have tools to play and check that your understanding of this concept is good. Clear? Okay. Do we understand parameters, total parameters, WBs, bias, inputs, outputs, and so on? Again, we review it. You have all the information in one slide, but something to review. Now, talking about this, network summary is the one that print that. Here. Fit. What is the goal of the method fit? Fit. And the parameter is the one for
Input.
help me. Do you remember that we have this fit in which we send 2 parameters instead of 1?
We use iterate, send 2.
Do you remember that you can call fit and you can play with iterators for the data set and specify the number of epochs that you want to run? Okay, if you do not do that, like we did in the first example, this is the oldest slides. Do we understand what is happening there? In particular, my question, how many epochs do we have in the program that correspond to this snip of the source code? You notice the question, right? It's like, I am going to show you these 3 lines of code, and I am asking for epoch. And if you have been here, the answer is like, yeah, this doesn't. Move to the next one. That is the only thing that I need to know. Obviously, if you have not been here, it's like, what? There is no variable epoch then. Yeah, really. Okay, good. Thinking about that, one important part in your exam, one thing that I am going to do, this picture, and I am going to give you more slides with this, but you need to know what is a confusion metric, moreover, understand a confusion metric, being able to identify a good one and a bad one, moreover, these numbers, these 4 numbers. What is the meaning of a 1? 0 and the values in between. Good. This one, copy paste in your exam, good or bad?
Good.
What do we know?
That
is the thing that you need to know. The diagonal is the important one, and if we have zeros in the other things, that is the best thing that could happen. How to calculate accuracy. precision, recall, and the F1 score. When you know the formula, yes, something that you need to remember. Sorry. Let's see, accuracy. What is the equation for accuracy?
Direct predictions by total number.
Okay, and which are the correct predictions?
2 plus
2 + 2.
And divided by? So in this case is 4 divided by 4. And that is the calculation of the accuracy or the precision? In accuracy? Precision. Accuracy. Good. All the correct ones, all the diagonal divided by everything. That is your first number, the first one here. So that one is this one. However, that is not the good one. That have a problem. What is the problem with accuracy?
You can detect only positives and leave out negatives.
It's like could be too good to be true because in particular you are not considering individual classes. Yes. Remember? Because it's basically all the good ones divided by all the bad ones. Yeah, but one class, this number can be really big and this one could be really small. And well, two together, it's not going to be 100 perfect like this one, but still the model is good, yes, but it's good with or for one particular class, which yeah, it's good, but not exactly something that you want to stop researching, right? So what are the solutions for that problem?
Precision for any class.
The what?
Precision.
Accuracy is not good, then we can move forward to the other two. One is precision, but also the recall, right? What is the equation to calculate precision and recall?
Precision is positive predictions for a class by total predictions for that class.
And recall?
Wrong prediction. Wrong. Correct predictions plus wrong predictions.
Yes. An easy way to remember things is both precision and recall are going to work with a column or with a row, 1 and 1. And that column or that row corresponds to one of the classes that you are trying to review. Remember? Okay, what about the F1? I am going to show you the equation, don't worry, but I want you to have the big picture. The big picture is accuracy, it's about the full table. Now, precision and recall is going to be about one particular class, column or row. And then we have the F1 score. Okay, this idea of the harmony. The division of the pressure. Okay, those three. Good. Obviously, the one that is going to be a better indicator, if you have the 4 values, the one that is kind of the better one, the one that is considering more elements, is the F1 score. Do you agree? Like you start with something that is too broad, like too general. It's good, bad, but I don't care about the categories, which is not a good idea. Then we move about the categories, different values per category. But then you have this value that is going to put together the 2 measures that you did in the category columns and rows. So this one is kind of more inclusive. Good. For numbers, you need to understand the numbers. In all the cases, 1. Good or bad?
Good.
Is the best value that you can have, doesn't matter which of the 4 metrics here. The worst one, there is no other option, right? Okay, good. So I give you the questions, please check them. In particular, you have this kind of pictures that I share with you. Accuracy is basically the good ones. Remember, through positive to negative, basically the addition of the line divided by whatever order. But there are some of them that have a particular name. I don't care. For the accuracy, use division. For the precision and recall, you have these slides as you need to remember. Again, precision through positive divided by that particular place, recall, true positive divided by that particular column. So you don't care about the diagonal, you care a particular place and then the column or the row, and that is going to give you precision of recall per class. What you have in your results in the library is this precision of recall, that is the average of the classes, and the library tells you, hey, that particular class maybe do not provide a value, I am not using the value, whatever. Not these small comments, but precision of recall per class, accuracy per problem. And then you have the possibility of using them to calculate the F1 score. And as you mentioned, this idea of the harmonic, that's the question. If I put this, or if I mention this harmonic, blah, 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 do we remember that this is this harmonic average, right? Or at least remember how to use this, the division of precision and recall, the multiplication, the addition, and this extra constant at the top. Good. I am going to play with this one question, literally. I am going to give you a confusion metric, a crazy metric, and I am going to ask you that one, good or bad. Can you calculate these four numbers? Those four numbers, good or bad, period. 10 to 15 points. Just show me that you understand the numbers, show me that you can calculate these values. So yes, this is the only thing that literally I am asking you to kind of memorize, because we are going to need to calculate these numbers. I need you to remember the equation. I really do not think that you need kind of notes or kind of, I mean, you can remember this equation memory, right? You have kind of the weekend to memorize this question. That's it. Good. So the questions. Five. The most complicated part. In some part, we start working with pictures, with images. For the images, I am not going to ask you to create a full model or a full network for images, but I am assuming that you can remember some things that I can use in some questions. For instance, if I put these lines in your exam, do you know what I am talking about? We use this data set a lot, right? So I can assume that I can ask you questions regarding this data set. Basically questions about things that you did in the homework. Basically questions that I am going to use to be sure that you did your homework. Do we remember what is the meaning of the parameters for the means data set?
Is total color black and white.
In particular, the last one is something that I want to be sure that you remember, the binaries, right? Something that I forget to mention in the previous lecture before your quiz, I think later the TA post the announcement. Do you remember for the convolutional network that there is an input that is channels? And something that I shared late as the channels is the number of layers that I consider for the image. In particular, I mentioned one layer of the value 1 if you have this picture in black and white, because if you have the picture in black and white, what you have is only one array with the numbers that correspond to the 0 to 255, black or white or the gray. Channel 1. If I want to use a convolutional neural net and I am going to have this channel 1 for the data set, can you agree with me that this parameter should be true? True, the binarization of the image. True, because the original data set color images, and I want to flat in black and white. Now, if I put here false, and therefore the pictures are not black and white, tell me, what could be the value for channels in the convolutional model? Two options, and you need to consider this. 3, good for this one, but if you have this concept of the alpha transparency, RGBCA, in some point could be an extra one, right? But for the data set 3, red, blue one. red, green, and blue, and for each of them, you have this number that represents the quantity, right? So channel 3 for the convolution, but you need this. Okay, so the 100, what is? The flash. Okay. For the NIMS data set, in particular for that one, if I show you this source code again, it's like we understand everything that is happening there. Why? 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 I don't need you to tell me if this is good or bad. You already use it. You already know that thing. But again, NIMS data set, we're playing with the images, and even though it's not the best one, but input, output, hidden layers, learning rates, how to specify them, and what this source code is doing. Good. Second time that I show you this source code, because again, the question with most value in your exam, one question is going to be about, give me this, for sure. Something that you need to remember is data sets, data set iterators. You feel comfortable with source code that is using that. Another thing that you need to remember, just because can be in a question there. Do you remember what is the number there when you create this object?
Number of them.
Yeah.
Hey, did you remember that in some homework I asked you to create a class evaluation from scratch? So I am confident that anything that I ask you about the class evaluation is something that you remember, because both you have used the evaluation class from the library, but also you create your own class evaluation. So how to calculate things, the equation that I mentioned before, is not only that I am asking you to memorize, but you already make a program using those equations. So again, hopefully I can ask that, and it's part of the things that we review. Good. So evaluation, moreover, what is doing this method? What is happening here? The while there is an iterator. This source code is something that you have in another slide. Hopefully it is clear that I am using this loop about the dataset iterator. Something is happening. I do the stats and I print the stats. I show you the stats, etc. Good. Notice that I am showing you a lot of small pieces of code, because I can use those in one particular question. I do not need to show you the full picture. I need to be sure you need to know what that particular part of the source code is doing without kind of having the full program. Right? It's just hopefully something that can happen. Anyway, the evaluation, the number of classes, and then for the customization of the architecture. Customization of the architecture. Something that we review that we can customize. In some point, we talk about these initial values for the W's. What are the initial values for your W's?
Random.
Oh, you have two options. You can use a constant, or you can use this random. Or you can use a random with some kind of validation of the mean and the standard deviation of the random values. Okay, what is the parameter in your architecture in the library in order to ask for constant values? Uniform. The fancy random values with this taking care of the mean and the standard deviation. Remember that, right? If you notice this keyword in architecture, this is what is happening. An initialization with random values taking care of not so random. So W's two ways, two options. Which one is better? Depending on your problem. In particular, when you are going to work with probabilities. Probabilities. like I am planning to use this, and I am planning to use this. Those two can be a good combination with random, not flat. More possibilities to get the W values correct quickly. So random probabilities used like the other two. We already talked about the sigma versus the ReLU. We already include, or I really mentioned the softmax for the probabilities, negative log likelihood for probabilities. And the only reason because I put that slide, tell me, best value for the error function, the squares.
0.
Worst value. 0 is the best. The distance between the two values, 0 is great, but the highest one is 1. Common error is not 1. It's not a percentage. Clear, right? Negative likelihood, best value. Worst value. Same as before. The good thing is 0. The close between the predicted and the real. The other is not 1 or minus 1. That is my only message here. It is not a probability. It is not 0 to 1 like other things. Right? It's a distance, and the distance can increase. Okay. Negative likelihood and square already there. I just want to mention the values. Now, one key thing for configuration. Updaters. There is this parameter, dot updater, in the neural network. Tell me, what is that? What is an updater? Is the thing that you use to calculate what? Predicted? The learning. Oh, two things that are going to be involved here. And it's important. The learning rate is going to be there. But when we talk about the updaters, we are talking about this equation that we use in the backpropagation phase. Right? Okay, what is the default thing that you use? The default thing, the original choice, the one that you have in several different examples, is the question at the top. What is the question at the top? The question at the top is this learning rate. That is the thing that is. And that one for the partial derivatives in order to calculate the background. By default, we use these partial derivatives. This partial derivative is what we call in this gradient descendant, right? That is the original one, the one that we choose, the one that is represented there with the triangle inverse and the function that we're using. Because remember, the function that we're using here implies the error and imply whatever function you're using for activation, like the sig mode, and imply all the inputs that you're using, all your x and your W. Is the full equation, partial derivative, and then multiply the learning rate, and that is going to give a value, and that value is the one that they're going to use to calculate the new W using the old W. Because basically what they're going to do is the new W is equal to the old W plus minus this thing, right? And this thing is the updater. The thing that we are using to add or remove from the W in order to get a new W. Now, the original updater is learning rate. The original updater is gradient descendant because it's to the partial derivative. Something that we can do is we can improve that. We can improve that. We review two ways for improvement. What if instead of just calculating a new gradient descendant, we consider this idea from physics and momentum. This idea of if something is moving, we can check how fast it's moving and use that idea to calculate the next one. Velocity. Can we calculate the velocity? Yeah, how fast the W's are changing. And as usual in any equation, you have the velocity and you have a constant that is going to multiply that thing. So this constant can kind of impact this equation. And then the new W is going to be equal to plus minus, not only the gradient descendant, but the gradient descendant plus minus the velocity. So it's a new factor. And you don't need to believe me, but this improves in some cases the calculation of the W. This thing, using the velocity with the constant, by the way, represent the mass, whatever, momentum. Now we can improve even more. Okay, it's exactly the same as above, but now the velocity and the coefficient, instead of being only here for doing plus or minus, let's use that also here inside with the equation that we're going to use to calculate the gradient descendant. We talk about this in one full lecture, but whatever. The only thing that you need to know is there are different ways to calculate the increment or decrement from the W, right? And that is what we call the updaters. All this. Except these two guys, the updater. Except these two guys, the updater. And so on. Options for updaters. What you have is, by default, without you specifying anything, is gradient descendant. Do you remember the other three options that we talked about? Hopefully the other three options that you tried in your homework. Adam. Nada. Nestor. Help me, which of this one is Nestor, right? The last one, top of the top. Did you remember how to use Nestor as an updater in your model? Did you remember this dot updater parenthesis and the parameter was what? An object from the class Nestor that receives how many parameters? I am pretty sure that there are two parameters. One of them, the learning rate. Good. What about Adam and Nathan? Both are the equation in the middle. Difference between them. What is the meaning of the N in Adam? Nestor plus something, Nestor plus Adam. And what they do? Don't worry, I am not going to ask that level of detail, but you have that information in the slides. Good? Used to testing. But at least I can ask you for Adam, Nestor, and the gradient descendant. Good. The last thing that I want to share with you, well, two things. One, can I ask you about listeners? Oh, yes, I can, and I am going to do. What is a listener? How do you implement a listener in a model? What is the goal of having a listener? Moreover, the source code to the implementation of one listener. Moreover, how to connect this listener with a particular model. Do you remember that we have this add listener source code kind of for the model? And the only thing that you need is to create a class that, as usual, implements something, in this case, training listener, and provide a particular method. And every single time that something happens in the model, this method is executed. Review listeners. And the last thing, and I am just going to finish with this, convolutional neural networks. The configuration of convolutional neural networks. I am going to ask you this, obviously this. In one question, you are going to need to create this convolutional and fully sampled layer. I am going to give you the architecture. The only thing that I need to be sure is if you can put that architecture in terms of the MQDA instructions, the builder pattern. Clear. Okay, guys, add this. See you next lecture for your exam. Thank you.